Well, hello, algebra class. Here we are again. We're going to jump into some more of chapter 7 today. I trust that things went okay so far in the first couple of sections. Today we're going to be looking together at sums and differences when we're talking about radicals. So just to get us kind of warmed up, here we have the cube root of negative 54x to the fourth. So the things you need to think about whenever you're simplifying something like this is what number times itself 3 times might be a factor of 54. So I might try, smaller numbers to start. So 2 times 2 would be 4 times 2 is 8. Does 8 go into 54? No. What about 3? 3 times 3 is 9 times 3 is 27. Does 27 go into 54? And the answer is yes. 27 times 2. So 27, we can take the cube root of that and get 3, and then have, again, a negative 3, right? And take that outside of the radical then, and be left with this 2. Now, of the x to the fourth, remember we can see that the x to the fourth can also be rewritten as x cubed times x. So it's this first part, the x cubed, that we can take the cube root of and just get x, and then leave this other x underneath the cube root. And so we should get an answer like this: negative 3x times the cube root of 2x. What about this next one? 3x squared plus 2x squared. Well, here, as long as these guys match each other, they have the same power that they're being raised to, we can just add the coefficients. So 3 plus 2 is 5. So we get 5x squared. And on this last one, notice that here we have to distribute this negative 3 into both of these guys. So when we do that, we would get a negative 6x and a negative 9. And then when we add these together with this 5x to start, 5x minus 6x is a negative x, and then we have negative 9. So negative x minus 9. Okay, now like radicals, are radicals having the same radicand and index? So in order for them to be like radicals, both the number that is above the radical sign and the number inside of the radical sign have to match each other. So whatever they are, they have to be the same. When they are, then we just add the coefficients that are in front of them. So if I had, for example, 2 cube roots of x plus a cube root of x, well, that would be like 1 cube root of x plus 2 cube roots of x, which would give me 3 cube roots of x. So we just have to make sure that both the radicand and the index match each other. Then you can add them together or subtract them. So first of all, what we're going to do in these problems, because they're not always going to be so simple where they give them to you already with the same radicand and the same index. So sometimes we're going to have to do a little bit of work beforehand to get to the same index and same radicand. Then we can add them together. So we're going to simplify each radical. Then we're going to combine like radicals by adding or subtracting their rational coefficients. So example 1a, we're going to simplify this guy. So the first thing we need to do is recognize what inside of this 32, what are our factors of 32? Well, we know it could be 2 and 16, and 16 would also go down to 2 and 8, and 8 would go down to 2 and 4, and 4 would go down to 2 and 2, right? So we've got 1, 2, 3, 4, 5. So 2 to the 5th. We could rewrite 32 as 2 to the 5th. What about this 8 right here? Well, we just realized from the previous thing we did, that's 2 and 4, and this would be 2 and 2. So that's 1, 2, 3, 2. So we could rewrite that as 2 to the 3rd. And 18, well, that'd be 2 and 9, and then 9 becomes 3 and 3. So you're going to be doing this kind of factoring a lot of these to figure out what things you can then actually take the square root of. So this first one becomes 4 square roots of 2, right? Because we could rewrite this 2 to the 5th as 2 to the 4th times 2 to the 1st. Remember, whenever you multiply something with the same base, then you add exponents. So we can flip that out the other way and notice that 5 is like 4 plus 1. And 4, remember the square root can be rewritten as, we rewrite this whole thing as 2 to the 5 over 2, which then that's like saying we've got 2.5, right? 5 over 2 is the same thing as 2.5. So we can rewrite this as 2.5. Well, 2.5, well, That's like saying 2 squared. So we've got 2 squared, which would be 4. And then we have a 2 raised to the 1/2 power. Again, that just gets rewritten as the square root of 2. So that's how we got to 4 square roots of 2. And the second one, 3 square roots of 8, notice we had 2 to the 3rd power. Well, that's like saying we've got 2 squared times 2, all underneath the square root. Well, this first part, 2 squared square root, is just 2. The 2 comes out to the front, and then that 2 gets multiplied by the 3, and we get 6. And then we have left behind a square root of 2, a 2 underneath the square root still, so it's 6 square roots of 2. And in this last one, we have 2 times 3 times 3. Well, that's like writing 2 times 3 squared, right? 2 times 3 squared underneath the square root. Well, we can take the square root of 3 squared. That's just 3. So we get negative 3 square roots of 2. And now notice that in each of these cases, let me erase this stuff so it's not in the way of the problem here now. Now notice that we have the same index. We have the same index with the same index with the same radicands. They're all square roots of 2. So we can now add or subtract coefficients. So 4 plus 6 is 10, minus 3 is 7. And so we get 7 square roots of 2. Let's do example 1b. Simplify the cube root of x to the 4th minus the cube root of 8x to the 4th. Well, notice that the first one, we could rewrite x to the 4th as x cubed times x. And the second one, we could rewrite as 2 to the 3rd, right? 2 times 2 times 2 is 8. And then that x to the 4th, again, we could rewrite as x cubed times x. Why have we done that? Well, because then the x cubed gets divided by a 3, right? We rewrite that as x3 over 3 and then x1 over 3. So this x3 over 3 is just x to the 1. So it just comes out here in front, and we leave the rest of it underneath the cube root of x there. And then on this guy, again, 2 cubed cube root of that is just 2. And then this guy, x to the 3rd, taking cube root of x to the 3rd is just x. So we get from that negative 2x cube roots of x. And now notice we have here and here, we have the same radicand, the same thing underneath the radical, and then we have the same index up above. So since those are the same, we can then add or subtract the coefficients. X minus 2x is just negative x. So we get negative x cube roots of x. What about example 2? Here's another one. We just need to simplify. Now remember, the first step in all of these is just doing the factors of the numbers underneath the radicals, trying to get them to match one another so that way we can actually add or subtract them all together. So first step, we should notice that with 72, 72 is 36 times 2. Well, 36 is 6 times 6. So we can take a 6 out of this 72, because it would be 36 times 2. We leave behind the 2, and the 36 we take the square root of, and we get 6. What about this guy? Well, I just said the square root of 36 is 6, but notice we have a negative sign. So we know, though, the square root of negative 1 is I, the imaginary number. So we can rewrite this as plus 6i. And the next one, negative 98, we need to recognize that 98 divided by 2 is what? It's 49. And what is the square root of 49? It's 7. So we can take a 7 out of that and we have left behind the square root of 2. And on the last one, remember again, we have a negative underneath the square root, which we can make that as I. We make that the imaginary number I. And then what's the square root of 9? The square root of 9 is just 3. So it's minus 3i. And now note, the things that are blue here are alike, and the things that are red are alike. So now we can add and subtract the things that are alike. So 6 minus 7 would be negative 1, so we'd have a negative square root of 2. And then 6i minus 3i would be a positive 3i. So we get negative square root of 2 plus 3i. And that's our answer. So just as radicals must have the same radicands and indexes to be like terms, exponential terms must have the same bases and exponents if they are to be combined. So if radicals have to have the same radicands and indexes, if the term has an exponent, they have to have the same base and the same exponent if we're going to combine them together. Let's look at a couple examples of this. Simplify 2 times 3 raised to the 16th power plus 3 raised to the 16th power. So notice, we have the base of 3 here, and we have the same base right here. We also have it raised to the same power in both cases. So since this is 2 of the 3 raised to the 16th, and we have over here 1 of the 3 raised to the 16th, we can add these together. Notice that if there isn't anything multiplied in front of it, it's implied that we have 1 of them, right? If we have this guy, there's 1 of them there. So what's 2 of them plus 1 of them? Well, it's just 3 of them. So that's like saying 3 times 3 to the 16th power. But notice now this base is the same as this one. This could be rewritten as 3 to the 1st power. Well, what do you do whenever you multiply 2 numbers that are raised to powers like this? Well, we can just, if we have the same base, we can add the exponents together. So 1 plus 16 is just 17. So it's 3 to the 17th power is our final answer. Example 4 says, simplify 5 times 4 to the 3rd power plus 3 times 2 to the 7th power. Now notice right now, we don't have similar bases, and we don't have similar exponents either, powers that is being raised to. So we need to work first to make these match one another, then we can maybe add them together. So let's see what we need to do that. Well, in the first case, notice that 4 raised to the 3rd power, we could rewrite that. We have a base of 2 here. What could we do to this to make this be the same base? Well, we could recognize that 4 is 2 squared. So we could rewrite this as 2 squared raised to the 3rd power. Now, you have to remember the rule. Whenever we have an exponent raised to another exponent, we multiply them together. So we could rewrite this as 5 times 2 to the 6th power plus 3 times 2 to the 7th power. Now, at this point, do we have the same bases? Yes. But do we have the same power? No, we do not. Notice it says 6 and this says 7. What trick could we use to make these match one another? Well, we could look at this blue one right here and notice that 2 to the 7th could be rewritten as 2 to the 1st times 2 to the 6th. Remember, whenever we multiply bases like this, we add exponents together. So we could rewrite this, because you could also rewrite this, right, as 2 times 2 times 2 times 2 times 2 times 2 times 2. Did I make another one? 1, 2, 3, 4, 5, 6, 7. I could rewrite it like that, right? Implied here every time is there's a 1. So adding those together, you get 2 to the 7th. Or I could just rewrite this as 2 to the 1st times 2 to the 6th. And that's what I want to do here. Why? Because now this will match this. So I have a 2 outside here, so I just multiply this 2 times that 3 that's in front of it. So 3 times the 2 is 6. So I now have, again, maybe I should erase this so we get this out of the way so now you can see this. We now have 5 times 2 to the 6th plus 3 times 2 to the 1st times 2 to the 6th. That 2 to the 1st times 3 is just 6. So we have 5 times 2 to the 6th plus 6 times 2 to the 6th. Now these both match, right? Both the base and the power that they're being raised to match one another. So now we can just add the coefficients. What is 5 plus 6? It is 11. And the final answer is 11 times 2 to the 6th power. All right, well, let's look at example 5. Simplify 5 times 4 to the x plus 2 raised to the 2x plus 3 to the 11th minus 3 to the 10th. Okay, so first thing we want to note is we're trying to find bases and exponents that are going to match one another. And we see here with this 4 to the x power that could be changed into a 2 squared. So we rewrite that as 2 squared raised to the x. And then looking at this 3 over here, this 3 to the 11th power, well, how could we make that look like 3 to the 10th? Well, we could rewrite that as 3 to the 10th times 3, right? Now we have a 3 to the 10th. So that's what we'll do. We'll rewrite this as 5 times now 2 to the 2x plus 2 to the 2x plus 3 times 3 to the 10th minus 3 to the 10th. Well, now we have similar bases with raised to the same powers in both of these cases. So now we just add or subtract the coefficients. 5 plus 1 would be 6, and 3 minus 1 would be 2. So we get 6 times 2 to the 2x plus 2 times 3 to the 10th. Now, we're almost done. Notice here this 6. There's 2 factors of 6 that are applicable here. It would be 3 times 2. So we can rewrite that as 3 times 2 times 2 to the 2x plus 2 times 3 to the 10th. And what then is this? 2 to the first times 2 to the 2x. Well, whenever we have the same bases, we can then add their exponents. So we can rewrite that as 3 times 2 to the 2x plus 1 times 3 to the 10th power. Or I'm sorry, plus 2 times 3 to the 10th power. And that's our final answer. Which brings us to your assignment. So your assignment is going to be 7.3, pages 298 to 300, numbers 2 through 32, and 50 through 56 evens. These last problems obviously are your cumulative review, but these guys are going to give you a lot of good practice of both adding and subtracting and simplifying these radicals and even exponents, making sure that you can work all of those problems. Let me know if you have any trouble. You can reach out to me through email or through text. I'd be more than happy to help you in any way that I can. God bless you guys. I'll see you soon.